Welcome student to geography class, geography form 1, and we are now on the second topic, which is the solar system. We introduced this topic in the last lesson, and today we are proceeding this topic by looking at the Earth's position and life activities. Earth's position and life activities. So this is to say that the Earth as the planet is one of the planets which is considered to support life. So we need to go into details and how the Earth supports the life. So the Earth's position and life activity is our major target for today's lesson. So the Earth supports life in this way, as in the first place, it receives good amount of heat and light to sustain life. This is because the Earth is at a good position where it is able to receive a good amount of heat as well as the light to sustain the life. That is why the Earth supports the life. The Earth also has good temperature that support existence of water and water sources. So the water which we have on the Earth is also supported by the Earth because of the good temperature. So some of the sources of water also which we have on this Earth that have been supported by the good temperature, which is supported by the Earth. And then we know that water is life. Without water, there wouldn't be life. That is why the Earth is support the life. The Earth's atmosphere is oxygen, and which supports life. Also, we're saying that the Earth's atmosphere is a source of oxygen, which supports life. So, in the atmosphere of the Earth, there are different types of gases. So, one of the major type of gas which is found in the atmosphere is oxygen, and oxygen is one of the major important gas for human beings or for the other things in the Earth to support life. So this gas is now important for the living things in the Earth. That is why we have the life on the Earth. The Earth's atmosphere shields it from ultraviolet radiation from the sun. We're also saying that the Earth also supports life because in the atmosphere of the Earth there is a shield which now protect the ultraviolet, protect from the ultraviolet radiation which comes from the sun. So it's like this shield blocks the ultraviolet radiation which comes from the sun. In other words, these ultraviolet radiations are more dangerous to human beings when they penetrate in the body of human beings. They can cause something like cancer. Now, because there is a shield in that atmosphere which protects us from that ultraviolet radiation, and then we're saying that the Earth supports their life. The atmosphere also acts like as an insulator and provides Earth with required nitrogen and carbon. The Earth acts like an insulator and provides Earth with required nitrogen and carbon. So these are some of the major factors of saying that the Earth's position and that supports the life on Earth. Now there are some other facts which need to be noted. This is now according to the solar system. So the Saturn is the only planet that has a ring around it. Another fact, Jupiter is the largest planet in the solar system. Now please take note of that. Earth is the only planet that supports life. So as you can see, we have been discussing the reasons as in how, or the ways as in how the Earth supports life. So we're saying that as a matter of fact, Earth is the only planet that supports life. So you will only find humans or rather living things only on planet Earth because there's life. The sun is the largest star near the Earth. So you also see that the sun is the largest star near the Earth. There is a possibility that every star could have its solar system and a life-sustaining planet like Earth. There is a possibility that every star could have its solar system and life-sustaining planet like Earth. Just a possibility. Shooting stars are meters that bends when they enter into the Earth's atmosphere. So if you look in the sky at the night, you see stars. So those stars, we're saying that there are meters now. So those meters now, they bend actually when they enter in the atmosphere of the Earth. So you have comets as balls of rocking floating in the orbit, and are often melt and produce a tailored light as they enter into the atmospheric zone. When a big meteorite falls onto the Earth, it sometimes creates a big depression called a crater. So in other words, when a big meteor, that is, now instead of maybe being held in the atmosphere, it falls down on the Earth, then that one causes what is known as a deep depression called a crater. So here there's a diagram of how a crater looks like. So this is the depression, and this is the position actually where the meteoroid are falling, and this now creates a depression. So this is the depression which is now created after that meteoroid hitting the Earth. So let's proceed by looking at the shape of the Earth. We need to know exactly what the shape or what shape that the Earth holds. So the Earth is flattened at the poles and baggy at the equator. So we can say that in terms of the shape, we say it flattens at the poles and then baggies at the equator. So the rotation of the Earth creates a centrifugal force, and that is the pulling force that pulls objects away from the Earth. However, the gravitational force holds objects tightly to it and avoids falling. It's the gravitational force now which pulls some object to be tightly to the Earth to avoid from falling. Every mass object has gravitational force, but however, the degree differed on the size of the object. Now, we're saying that every mass object has gravitational force, but however, the degree differed on the size of the object. For example, if our body has a small gravitational force of in other words, gravitational force can say as the force of attraction. So it has small gravitational force because of its size. So what are some of the factors now that affect the gravitational force? Factors affecting gravitational force. So one of the factors that affect gravity is mass of an object, the mass of the object. The bigger the mass, the more attracting or attraction force is. So the bigger the mass, the more the attraction force. So for example, the Jupiter has the strongest gravity than the Earth due to its large size. So when you look at the size of the Earth and size of the Jupiter, they're different, right? The Earth is smaller, and because of that, has smaller gravity or smaller gravitational force. Or why that a Jupiter is huge, it's a big planet, and because of that, it has stronger attraction force. The other factor is the distance of an object or a mass. If the distance is closer, the gravity becomes much stronger than the object at a distance. If the distance is closer, the gravity becomes much stronger than the object at the distance. Now this means that when an object is close enough to the gravity, it will be more stronger than that object which is at a far distance. Please take note that our muscles can briefly overcome gravity as we jump the air, but soon comes down. So in other words, we're saying that our muscles sometimes can briefly overcome the gravity for a very small period of time, but at the same time, you can also be pulled down. That is why when you jump up, you also comes back down. When you jump up, you comes back down. So that which is now pulling you down, it is the gravitational force from the earth. So let's see now some of the evidence which supports that the earth is spherical in shape. Evidence of spherical shape of earth. Number one, the first evidence is the ship visibility. A moving ship away from the observer appears to be sinking into the water. An approaching ship on the sea appears to be rising from the deep of the water. So this is like an opposite way. Now when you're seeing a ship which is now moving away from the observer, you may be seeing that ship is sinking. While now the observer now will see that that ship is coming toward that person, the observer, you see that if the ship is now rising. Now, however, if the F would flight, then the ship wouldn't have behaved in that way. So it would have just disappeared and disappeared. So there's the diagram. So in the first, you can see an observer here. So when the observer is seeing the ship is coming towards, it seems as if it is rising. While now when it is moving away, it seems as if it is sinking. This is possible because the earth's surface is curved. So in other words, we're saying that the earth is round or is spherical in shape. Now, on the other hand, if now then the earth was flat, then we would assume that the earth has in the ships now been sinking. I would just appear and disappear. Still on the evidence support the earth is spherical around, then the other evidence is aerial photographs. The pictures that are taken from the airspace clearly shows that the earth is spherical or the earth is round. Those pictures that are taken from the upper spaces, they are showing that the earth is spherical or round. So we have also circumnavigation of the earth. So the journey around the earth makes one to come to the same point or position where he or she started. So if this is possible, because if you can start now, move around the earth, and then you find that you reach or you come back at the point where you started. So this is possible because the earth is round. For instance, traveling by air towards west would make one to come to the same point but a different direction that is in the east. The other evidence is since the sunrise and sunset. Since the earth rotates from west to the east, those on the east see the sun earlier than those on the western side. The other evidence is the earth is curved horizons. So here the earth appears to be touching the sky in the earth's horizon. And the other evidence, the last evidence now, is eclipse of the moon. The eclipse of the moon. So the shadow of the earth curved that is casted on the moon when the moon is appearing blocked appear to be round. Now you have a moon, and that moon, when that moon is now where the shape of the earth is being casted, and that shape shows that the earth is round. So here it is the eclipse of the moon. So you have the earth and you have the moon and then you have the sun. So the shape of the earth, which is round, will be shown on this moon, which is round. So what are some of the effects of the shape of the earth? effects of the shape of the earth. Some of the effects of the shape of the earth are it results in variation in the heating of the earth surface by the sun, hence affecting rainfall. It results in variation in the heating of the earth surface by the sun, hence affect rainfall patterns and its distribution on the earth, which affect human activities. Now, since we're saying that the earth rotates, now when it's rotating, it means that this side of the earth, it will directly face the sun, and the other side will not face the sun. So the side which will face the sun, it will have a different heating as the other side. So where there is much heat, sometimes this frustrates the process of rainfall, and then the other side there may not be rainfall, while the other may be receiving rainfall, and then which may affect the activities of humans. The other effect is that it's possible to circumnavigate the earth without fear of falling into the daygods or abyss. So it is possible to circumnavigate the earth without fear of falling into the daygods. So those are some of the effects of the earth, the shape of the earth. Now let's proceed by looking at movement of the earth. The earth moves into two ways. So there's rotation and revolution. What is rotation of the earth? It's the turning of the earth on an imaginary line that passes through the center of the planet, connecting South Pole to North Pole. Rotation of the earth, this is the turning of the earth on an imaginary line that passes through the center of the planet, connecting South Pole to North Pole. It is the spinning of the earth on its axis once every 24 hours. So the earth completes its rotation after every 24 hours. The axis stands at an angle of 66.5 degrees to the orbital plane. The axis of the earth, where the earth rotates, stands at an angle of 66.5 degrees to the orbital plane. So what are some of the results of the rotation of the earth? The results of the rotation of the earth includes: first, it results into the sunrise and sunset. It results into day and night. It results into deflection of wind and ocean currents. It results into difference of 1 hour between meridians that are 15 degrees apart. The rotation of Earth also results into the rising and falling of ocean tides every day due to the pull of the moon gravity on oceans. So those are some of the effects of the rotation of the Earth. Now we're done with the rotation of the Earth as one of the movement of the Earth. Now let's see revolution. What is revolution? Revolution is the journey of the Earth around the sun or its orbit once in every 365.25 days. So 365.25 days, in other words, can be translated as in the year. So we can say that the Earth now moves around the Earth on its orbit once in every 365.25 days. So this translates that in the only 1 year the Earth moves around the sun on its orbit. So what are some of the results of the revolution? Number one, the first seasonal changes such as summer, winter, spring and autumn. So the first results of the revolution is seasonal changes such as summer, winter, spring and autumn. So the season may change due to the revolution of the Earth. So the other results is that changes in the duration or length of the day, night at different times of the year. So sometimes when the Earth revolve around the sun, the length as well, the duration of the day changes as at different times in a year. Results is changes in position of the overhead sun at different times of the year. Changes in the position of the overhead sun at different times of the year. Now, these were some of the major results of the revolutions. Reaching this far, we've come to the very end of the topic, the solar system. So we have discussed all the matters which you were supposed to know regarding the topic solar system. What is now remaining now is for you students now to go to the library and see other sources and read more about the solar system. Now, but before I introduce the new topic, there is some questions for practice, which you students now you're going to see them, and then at your free time you will need to provide possible answers. So here are some of the end of topic exercise. End of topic exercise. So these are the questions now which are being generated based on what we have discussed in this topic of solar system. So these are some of the questions. Please find some time, go through these questions and try to answer them. Right. Like I said, that's the end of the topic. Now we're moving on by geography with a new topic. So the new topic which we are going to discuss in the next lesson is the hydrosphere. The hydrosphere is our next topic of discussion. So as our agriculture, you need now to go to the library or find another source and read more in advance about the topic, the hydrosphere, so that when we come next time, we will be able to follow this topic more easily. But for now, let me stop here. You have been a good student because you are listening. So for now, let's stop here. Have a great day. Goodbye.